about rotations. But first, we've got a work problem for you. So what you're asked to do here is to solve for x. This might look a little unusual to you, but hopefully you look at it and recognize that this is a straight line and that these two 3x plus 1 and x minus 21 doodads here actually are representing the measurement of this angle. And since this is a straight line, this measurement equals 180 degrees. So what we know then is that these two added together, x minus 21 plus 3x plus 1 equals 180. And I noticed that right over here, the 21 I kind of made into a plus sign. That should just be a 21 plus 3x plus 1 equals 180. All right, let's circle the like terms. We've got x and positive 3x. Combined, those become 4x. Then we have negative 21 and plus 1, so that would net result would be negative 20 equals 180. And we're trying to solve for x according to the instructions. So we're going to add 20 to both sides. And 80 plus 20 is going to equal 200, or 180 plus 20 is equal to 200. And then that's set equal to 4x. So then we divide both sides by 4. And that gives us a nice number of x equals 50. So in this case, x is 50. Now, if they wanted us to, they could ask us to take the 50 back up here and stick it in for each of these x's and actually calculate the value of each of those angles. But we won't do that at this time because we want to move on. So we're talking about rotations. And a rotation is the action of turning or spinning around the center of an axis, preferably like the origin or across the y-axis or the x-axis, or some similar point where you can rotate it, as you see by the arrow here. In rotations, the size of the figure doesn't change, the anterior angles do not change, the shape does not change. They are both considered congruent images before and after a rotation, but the way they're sitting does change, and that's what we're going to investigate right now. Okay, so what we're going to do is we're going to go into Alex and show you how those rotations work. And this is quite literally an example of what you'll see in your Alex assignment today. So in the first question, you might see something like, for each pair of figures below, choose how they are related. Well, if you notice, these are the same shape, and it looks like they've just slid apart from each other, so that would be considered a translation. This looks to me like this rotated across the x-axis, so that would be a reflection. This looks like another slip or push, whatever you want to call it, so that's a translation. And in this case, you actually have the arrows rotating like this, so that would be considered a rotation. Okay, another kind of problem that we may encounter is one like this, where it says rotate the figure 270 degrees clockwise about the origin, and then answer the questions about that statement. Well, what's nice about this is they've got a little axis of rotation tool, and so we're starting at 0 degrees here, and then to go 270 degrees in a clockwise direction, we just go rotate that down to 90, 180, and 270 would be that far around. So after a 270 degree clockwise rotation, the new figure is right here. So then we go answer the questions. The final angle measures are the same as the original angle measures. Well, that's true. The final side lengths are longer than the original. Nope, they look like the same to me. The original figure and the final figure may not be congruent. False, they can't change shape in the rotation. If two sides are parallel in the original figure, then those sides may not be. Somehow they may not be parallel in the new figure, false. So that's the idea. So a lot like when we were looking at translations, isn't it? Okay, let's look at another sample problem that we could run into. This one says triangle XYZ is rotated 90 degrees counterclockwise about the origin. As a result, we have X prime, Y prime, and Z prime as shown below. So here's the original, here's the new one. So they give you the three coordinates for the original 3 points. Now we're going to find the coordinates for the next 3 points and then answer this question B related to this. So if we look at, we'll start with X prime. So that would be -1, 2, -3, -1. So that would be -3, -3, and -1. All right, and then Y prime, that would be -6 and 2. So -6, -6, and 2. Oops, 2. And then the last one, Z prime, that would be -4 and 8. So -4 and +8. So there's our three new points in our rotated image. Now what we're going to do is see if there is a rule here that describes what happens to the X and the Y value. So if you look at the new ones compared to the old ones, you notice that the original X value in our first point moved over to become the Y value. So the X became the Y, if you notice that. So you got -1, 2, and 8 in the Y position. So what about the Y values? Well, they moved to the X position, but they also became their opposite. So what we're looking for is a rule that shows X becomes negative, X becomes Y, or excuse me, X becomes -Y and Y becomes X. So let's take a look. So what we're going to come down here and X, remember all of the X values moved into the Y position. So X becomes the Y value. Oh, look at that. So X became the Y value. And then the Y value turned into the Y value turned into here's the Y, original Y value, it became the X value. So Y became the X value. So we're looking for Y and X. Excuse me. We're looking for Y and, well, double check again. So you've got the X value becomes the Y value, and the Y value in the first one becomes the X value. So it's Y becomes the -X. So Y becomes the -X, and X becomes the Y. Okay, so it looks to me like it's this rule right here. So that's how you figure out what the rule is based on what you see in the differences of these points. And then lastly, another question we can take a look at is this one. Rotate the figure 90 degrees clockwise about the origin. Then decide if the statement about rotated figures is true or false. Okay, so there's our figure. It looks like it was rotated, let's see, 90 degrees counterclockwise. So let's go back up to our original spot. There it is. And remember, counterclockwise is this direction. So if we rotate that counterclockwise like that, oops. And sometimes it helps if you're further out on the end of this arrow when you grab a hold of it. Okay, there's a 90 degrees counterclockwise rotation. Now let's read this. The final side lengths are the same as the original side lengths. That's true. The final angle measures are the same as the original angle measures. That's true. If two sides are parallel in the original figure, then the two sides are parallel in the final figure. That's true. The original figure and the final figure may not be congruent. Well, that would be false. If all of these other things are true, then it would have to be a congruent image. All right, so I think we're about there. Let's just see if there's any other kinds of questions that might catch us for a surprise. So there's another one where you're going to do a rotation about the origin and then see what happens. So we understand that. Now on this one, in each part, rotate the solid figure about the origin exactly onto the dashed figure. If it's not possible, click not possible. So basically what you're going to do is you're going to grab this, rotate it around and see if the original image will rotate onto the new image exactly. Okay, that looks pretty good. So that works, didn't it? What about this one? Let's rotate this around. And as we get close, look, no matter how we come across there, it doesn't quite fit. Just a little bit off, so this one would be a not possible. So that's how you do those different questions that are going to be on our assignment today from Alex. So good luck on today's assignment.